After completing this lesson, you will be able to understand solid and void geometry, create a pile family, work with reference planes, work with family parameters, and work with shared parameters. The objective domains covered are 2.2a, create or delete an instance or type parameter, 2.2b, determine the appropriate parameter discipline, type and grouping, 2.3c, add reference planes, lines and dimensions, 2.3d, create geometry, and 2.3e, associate dimensional parameters. There are 5 different methods to create solid and void geometry within the family editor. These range from a simple extrusion to complex shapes formed from blends and swept blends. The most common types for structural families tend to be extrusions or sweeps. An extrusion simply takes a profile and extrudes it upwards. However, a sweep takes a profile and allows you to sweep it down a complex path. Void geometry is used to cut from solid geometry. This is useful when creating penetrations or recesses into solid geometry. You first create your void geometry and then use the cut command to cut this from the solid. Note that solids can also be joined to form monolithic shapes. So we're currently viewing Revit's home screen. In the home screen, we can create new families. Go ahead and select New. You're then presented with the New Family dialog box. Here we can select a template. The templates have a file extension RFT, and each one of them will generate a specific family. For example, if we want to create a structural foundation, you can see here that we have structural foundation. However, if we want to create a structural column, we have structural column template here. Another option is to use generic models. The benefit with our generic models is we can choose the type of hosting we require. So for example, if I was creating a pile family that needs to be hosted onto the face of something else, I could choose here generic model face-based. In this example, I'm just going to go ahead and use generic model. Let's select Open. We are now in the Revit Family Editor. You can see the ribbon structure across the top is very different from the project environment. So we have a Create ribbon here, and on the Create ribbon we have solid forms. You'll also notice that we have the same forms that create voids. On the Create ribbon, select Family Category and Parameters. In the Family Category and Parameters dialog box, you'll notice that the current category is Generic Model. We're going to change this. This is going to become Structural Foundations. By selecting the family category, this will change the entire behavior of the family when we use it in the project environment. Also, we'll have different family parameters available in the lower half of the dialog box. Note that these same family parameters are also available in the Properties palette. So here you can see that we have Always Vertical selected. Well, that will be quite good for a pile family. Generally, sometimes we might want a raking pile, but in this case, our pile is always going to be vertical. The material for model behavior, I'm going to set to concrete. For example, if we were creating a piled wall, we might want these piles to blend together. And I also want the ability to cut with voids when loaded, so I'm going to select that option as well. Let's go ahead and select OK to our Family Category and Parameters dialog box. Next, we create the parametric framework. The parametric framework is essentially a group of reference planes and reference lines that we add dimensions to. It's very important to get this framework correct before we start adding geometry. The parametric framework that we create will also affect how the family operates in the project environment. Generally, most families will have a minimum of 2 reference planes already created in the template. If we go ahead and select the 2 reference planes here, you'll notice in the Properties palette, these 2 reference planes define the origin. We can change this if we want to. We'll also notice here that these reference planes are pinned. We're going to now go ahead and create some additional reference planes. Click the Create ribbon and then select Reference Plane. On the Context ribbon, we have the ability of drawing a line or picking an existing piece of geometry. We'll go ahead here and select a reference plane up the vertical path here. A little tip here is if you hold down the Shift key, the reference plane will be drawn orthogonally. We'll also draw another reference plane horizontally. So again here, I can select a position, hold down my Shift key, and place that horizontal plane. We'll then go ahead and select Modify. Now what I want to do here is create some symmetry around these fixed work planes. To do this, I can simply mirror the reference planes that I've just created. So I'm going to go ahead and select this vertical reference plane here. And on the Modify Context ribbon, I'll go ahead and select Mirror Pick Axes. And I'll repeat that for my horizontal plane. So I now have some symmetry around my reference planes. I want to ensure that this symmetry is persistent when I create the family. To do this, I'm going to add some aligned dimensions and then make them equal. On the Quick Access toolbar, select Aligned Dimension. We'll then select our 3 vertical reference planes and then position the dimensions in between the reference planes, somewhere here. You'll notice that when 3 or more elements are selected, we have the ability of creating an equal constraint. Let's go ahead and make these equal. We'll repeat that for the 3 horizontal planes. Place the dimensions down and make them equal. We now have our parametric framework set up. If I select one of these reference planes on the left-hand side, I can flex the reference plane. To flex the reference plane, I can use the left and right hand cursor keys. And you'll notice as I move the cursor keys backwards and forwards, the planes respond symmetrically. I can do the same for my horizontal planes using the up and down cursor keys. Next, we create some parameters to control our pile family. On the Modify ribbon, select Family Types. In the Family Types dialog box, you'll notice that we've already got length, width, and foundation thickness created. These were created automatically when we selected the category Structural Foundations. However, none of these are useful for our pile family, so we're going to go ahead and create our own parameter. Click New Parameter. We'll begin by creating a parameter for pile diameter. It's important to note here that when you use parameter names, they are case sensitive, so you need to choose a standard and stick to that. Here, this is going to be a type parameter. The discipline is going to be common, and the type of parameter will be a length because it's a dimension. And also here, we want to group the parameters under dimension. The name pile diameter is pretty descriptive, but if it wasn't, I could use Edit Tooltip and I could create a tooltip to give additional help. Let's go ahead and select OK. You can now see that we have pile diameter set up. So I'm initially going to set this to 12 inches. Let's go ahead and select OK. We will now create some dimensions and assign our new parameter to those dimensions. On the Quick Access toolbar, select the Align Dimension command. We'll place a dimension here and another dimension here. I'll then hold down a Control key and select both of these newly placed dimensions. On the Context ribbon in the Label Dimension panel, you'll note here that we can select that newly created parameter, pile diameter. Note that the reference planes have now driven to that new dimension. I'm now ready to create some geometry. Let's select the Create ribbon. And in this example, we're going to go ahead and use extrusion. On the Context ribbon, I'm going to select Circle. Let's zoom in to our reference planes. And here I'll select the intersection of the 2 reference planes and sketch out my circle. I need to control the diameter of this circle, so on the same context ribbon, I'm going to select Diameter Dimension. I'll then place a diameter on my circle. Once again, I'll select that dimension that I've just created and again assign that pile diameter. Once this is complete, I'll select Finish Edit Mode. And my solid geometry is created. Next, we control the height and embedment of our pile. To do this, switch the view to the front elevation. You'll notice in the front elevation that we have a reference level. This is going to be the level that the pile is placed at. Now, the pile is going to want to project above the reference level, which is going to be the embedment into the pile cap. It wants to have a depth to the toe of the pile. Both of these parameters will need to be set up with reference planes. So let's go ahead and create two new reference planes. Select the Create ribbon and select Reference Plane. We'll sketch a reference plane here to represent the cutoff level and another reference plane down here to control the length of the pile. You'll note here that we can select our extrusion geometry and we have shape handles on top of this geometry. We can drag the shape handle to meet the reference plane and then constrain that using the padlock. We'll do the same at the bottom here and once again constrain it by locking the padlock. You'll now notice that as I drag the reference plane up and down, the pile's length will adapt and change. So we're now ready to place down two new dimensions that we can control the embedment and the overall pile depth. On the Quick Access toolbar, select Aligned Dimension. First, I'm going to dimension the pile length. So I'll dimension from this top reference plane to the bottom reference plane here. Select the dimension, and this time we're going to create a new parameter using this icon here. The difference here is it won't ask us to select the type of parameter. This is predefined because we've started by selecting a dimension. So here we can type in pile length as our parameter name, and we'll accept the rest of the defaults here and click OK. I need to create another dimension. This is going to attach to the top reference plane here, and I also want to attach to the reference plane here. Now you may find that it gets the reference level, so you'll need to use the Tab key to make sure that the reference plane is in fact selected. So again, we can now select this dimension here. On the context ribbon, we'll select Create Parameter, and here I'm going to call this one Embedment, and click OK. If we now switch to our 3D view, we can now see our pile in 3 dimensions. We can give it a final check by selecting Family Types, and in our Family Types dialog box, we can now flex the parameters just simply by giving them new values. So here you can see we currently have a pile length of 10 feet and 11 inches. Let's change this to 6 feet and click Apply, and you can see the pile length changes. Again here for the diameter, I might reduce this perhaps to a 10-inch pile, and again hit Apply, and again we can see that change. Okay, so we'll now put this back to some starting defaults here. So we'll have 12 feet there, and we'll have a pile diameter of 1 foot. We'll also set an embedment in here of perhaps 8 inches. Okay, so there's our default pile set up. The last few stages will ensure that we can apply a structural material to this pile and of course save it. So to apply a material, let's select the pile, and you'll notice in the Properties palette we have Material. Now of course I could hard code the material by adding it in here, but what I want to do is associate a family parameter. Because the category is already set to a structural foundation, Revit automatically creates a structural material parameter for us. Let's go ahead and select that. So now you'll note that when we go into our Family Types dialog box, this structural material here will control the pile's material. Finally, we can go ahead and save. So here I'm going to type in situ pile and click Save.